So we've already really done all the equation steps. It's just that our equations are going to get a little bit more complex as we move along. And today we introduce the idea of an equation that has infinite solutions and an equation that has no solution at all. And it really gets down to something simple like this. This equation here, x minus 7 equals x minus 7, has infinite solutions because any x I plug in is going to make it true. If x is 10, 10 minus 7 equals 10 minus 7. If x is 100, 100 minus 7 equals 100 minus 7. Any number I can think of, if I plug it in, it will always be true. This equation has infinite solutions. Now, if you're not paying attention and you're just solving, you might get rid of one of the variables and take an x off each side. Notice what happens when you subtract x. You get negative 7 equals negative 7, and there are no variables left. So you know something went wrong. And then at that point, you have to look back and say, oh, that's because they were exactly the same. When they're exactly the same, any point I plug in will make it true. Also notice that this statement is true, and that's a clue that the answer is all real numbers. Reals are positives, negatives, fractions, decimals, integers, that's like negative 3 and 3, everything you can think of. In WAMAP, the assignments we do, they often use the symbol infinity, a sideways 8, to mean there are infinite solutions. So if you look at the equation to the right, negative 2x plus 5 equals negative 2x plus 5. Again, they're exactly the same. Any number I plug in for x is going to produce the same values on the left and the right side of the equation. They're always going to be equal. And so any number I plug in works. The answer is all real numbers, or they're infinite solutions. So if we solve this, we get rid of one of the variables. Again, the same thing happens. We get down to 5 equals 5. It's a true statement, and so the answer is all reals, all real number. Just like over here, the answer is all reals. So when do we get a no solution? Well, that's when we have the same variable on each side, but we've added different things. If I take a number, the same number, I subtract 7, and then I take that number and add 5, they're never going to be equal. This will never be true. They will never be equal. That's a no solution. But again, if you're solving this, just imagine there's an equals there, and I take an x off each side to get rid of one of the x's. I get negative 7 equals 5. Oh, wait a sec, that's not true. Negative 7 is not equal to 5. That's, again, a clue that this is a no solution. The variables drop out, you get a false statement, so the answer is no solution. So again, look at the last example. If the variable piece is the same and you've added different numbers to it, they're never going to be equal. And if you add 2x to both sides to get rid of one of the x's, the variables drop out. You get 5 equals negative 3. This is a false statement, so the answer is no solution. You'll see that some books use the symbol circle with a slash through it for no solution. In WAMAP, typically they use D and E, and that means is shorthand for does not exist. So the rest of this video is examples from your assignment. So I'm going to do some problems with you, problems with fractions, problems that have no solutions and have infinite solutions. So you have lots of examples to look at if you have trouble. So this first one, we're going to solve the equation. We distribute the 5, we take the 5 to both, and we get 5x minus 25 equals 5x minus 25. Well, we know the answer right here now because both sides are exactly the same. Any x I plug in is going to make this true. So the answer is all reals, every number that works. In WAMAP, they'll have you use infinity. To do that, you type 2 lowercase o's, but infinity is a sideways 8. And the answer is all reals. Now, our algebra book says all reals. For this next one, same idea. We'll distribute the 3. 3 times x and 3 times 4, 3x minus 12 equals 3x plus 2. Again, notice the variable piece is exactly the same, but I have different numbers added and subtracted from it. If you take the same number and subtract 12, and then take the same number and add 2, they're never going to be equal under any circumstances. The answer is no solution. And we use this symbol sometimes. And in WAMAP, you will say DNE. The solution does not exist. Here's some more examples. In this one, we're dividing by -5. I always solve using the inverse operation. The inverse of dividing by -5 is multiplying by -5. So I multiply both sides by -5. Remember, -5 is over 1. I have something above and below, so they will cancel, and I get r equals -15. For the second one, 8 minus t equals 15. I'm going to get the t by itself. This is a positive 8, so to get rid of it, I would subtract 8. Don't forget the minus on the t. That's a negative t equals 7. Now, there's a 1 in front of that t, actually a -1, and it's -1 times t. So divide both sides by -1, and t will be -7. For question 3, whenever possible, simplify. Basically, if you see 3 or more things on one side, you know there's stuff you can combine. So in this case, I can combine the +3 and the -4, and that is a -1, so I'm writing x minus 1. I'm going to get x by itself. I have to get rid of that -1, so I add 1 to both sides. And -3 plus 1 is -2, so x is -2. Question 4, I know that the 5 is the coefficient. It's the last thing I get rid of. I'm trying to get x by itself using the inverse operation. So the first thing I'll do is get rid of the +3. I'll -3 to both sides. 5x equals 20. Now that's 5 times x, so I'm going to divide to get rid of that 5, and I get x equals 4. 20 divided by 5 is 4. More examples, several with fractions. I need to get rid of division by 7, so I'm going to multiply by 7. Now careful, I'm going to take this side by 7 and this side by 7. But because of the subtraction, I have to distribute. I have to take the 7 to the first one and the second one. There are 2 terms in there separated by the subtraction. Both get multiplied by 7. Here the 7's cancel, and I get n minus 7 times 7 is 49. -4 times 7 is -28. Now to get n by itself, I'll just get rid of that -49, and I'll add 49 to both sides. And I'll go to my calculator and punch in -28 plus 49, and the calculator says 21. So n equals 21. Notice that you can plug that back in, your original question, and check it real easily. If I get rid of all that stuff there, then I can see that if I plug in 21, 21 divided by 7 is 3, and 3 minus 7 is -4. Since it makes the equation true, it's the correct solution. Question 6 brings up simplify. See how there's 3 or more things on one side? That means you can simplify. There's stuff I can combine, and that would be the +7x and the -6x. So I get -9 plus x. 7x minus 6x is +x equals -8. Only one more step. Get rid of that -9. Add 9 to both sides, and I get x equals 1. X equals 1 is my answer. For question 8, I need to get rid of division by 7, so I'm going to multiply by 7. Everything gets a 7. Notice there are 2 terms over here, something that takes getting used to. This is one term because of the fraction bar. The fraction bar makes it one thing, it groups it. A minus 4 is divided by 7, and it's multiplied by 7. So the 7's cancel. That leaves us with a minus 4 plus, you multiply by 7, 7 times 8 is 56, equals 7 times 3, 21. See how there are three things on this side? That means I need to simplify. Negative 4 plus 56 is 52. A plus 52 equals 21. Now I can take a 52 off each side, and again I'll go to my handy calculator. 21 minus 52 is negative 31. Negative 31 is my answer. For question 9, just like question 8, I'm dividing by 7. I need to get rid of dividing by 7, so I multiply by 7. Every term gets that 7. Terms are separated by addition, subtraction, and equals. So I'm multiplying both sides by 7. On this side, I had to distribute and take it to both terms. And the 7's cancel. I'm going to get negative 2b plus 9 minus 63 equals negative 56. Look, I just noticed there are three terms on this side. So I need to simplify. I need to take 9 minus 63, and that is negative 54. So this is negative 2b minus 54 equals negative 56. And I'll add 54 to both sides, add 54, and I get negative 2b equals negative 2, and I'll divide by negative 2 and cancel, and right there's my answer. That simplifies to positive 1. So B equals positive 1. There's my answer. Last two examples from your assignment. Enter the value of x that makes the equation true. That just means solve it. It's a different way of saying solve it. But the value you get if you plug it in will make the statement true. Just like the last couple, I need to get rid of fractions. Every terms are separated by addition, subtraction, and equals there. Both sides get multiplied by 2 here. I need to get rid of division by 2, so I multiply by 2. When I multiply by 2, the 2's cancel, and I get 6x minus 8 plus 2 times 5x is 10x equals 24. 6x plus 10x, notice that I'm simplifying. There are three terms there. That's 16x minus 8 equals 24. Now I'll add an 8 to both sides and get rid of that negative 8. And the coefficient is the last thing I'm going to take care of here. 16x equals 32. I'll divide by 16, and I get x equals 2. For question 11, careful. I would point out that this is the same question. 6x minus 15 divided by 3 plus 4x equals 13. That is exactly the same question. If I multiply this by 1 and divide it by 3, I get that right there. Either way you look at it, when you distribute 1/3, you don't need to get rid of fractions. 1/3 times 6 is 2. It's 6 divided by 3. 1/3 times 15 is 5. It's 15 divided by 3. And notice right here, let me change colors, that I divide both of these by 3. 6x divided by 3 is 2x. Negative 15 divided by 3 is negative 5. Now I can simplify. I've got 2x plus 4x. That's 6x minus 5 equals 13. The coefficient is last. Always take care of the coefficient last. Add 5 to both sides. So 6x equals 18. Divide by 6. Get the x by itself, and you get x equals 3.